today's session, we are continuing with the topic memory management. Myself, Kunal Buncha, your instructor. In today's session, we are going to discuss memory allocation policy. Before going to discuss memory allocation policy, let us recall our content of previous lecture, in which we have discussed there are three main criteria when we are talking about memory management in operating system. One is size, second one is per unit cost, and the third one is nothing but access time. And out of these three parameters, two parameters, size and access time, are contradictory in nature. Yes, so that is, if you want to achieve these two criteria simultaneously, we need to use the concept of memory hierarchy. So that we have seen how we can achieve these three criteria simultaneously with the help of two different types of memory. One is secondary memory and another one is main memory. So by considering that memory hierarchy come into the picture, we need to understand the concept of memory allocation policy. So let us start memory allocation policy. But before going to discuss memory allocation policy, the operating system responsibility with respect to memory management is nothing but address translation, and second one is memory allocation policy, or we can say space allocation policy. So there are two main responsibility of operating system with respect to memory management. Okay, so one is address translation and second one is memory allocation policy. So in this particular session, we are going to discuss the second strategy in detail with the help of example. So before going to discuss memory allocation policy, we need to discuss some introductory part of address translation, because address translation is one of the responsibility of operating system with respect to memory management. So let us discuss address translation first. So to understand the address translation, let us discuss this thing with the help of this figure, in which we have already discussed the concept of memory hierarchy. So same figure we have taken over here, and with slight modification. Means in the case of memory hierarchy, there are two types of memory. One is secondary memory and another one is main memory. So as we have discussed in process management, if any process wants to execute in the CPU, that process needs to reside in main memory first. Yes, and then CPU can execute that task. So it means CPU can directly deal with main memory. But there is a problem. What is the problem? That is nothing but address translation. What it means? So if we have a program which stored in secondary memory, and if that program needs to be executed in the CPU, so first of all, that program needs to be shifted from secondary memory to main memory with the help of operating system. And once it resides in main memory, still we cannot directly execute, or you can say CPU cannot directly execute that program. Why? Because CPU always generates logical address, and main memory cannot be fetched with the help of logical address. Main memory can be accessed with the help of physical address or hardware address only. So this is the problem, because if you want to execute any process in the CPU, okay, the CPU needs to contact to a main memory, but main memory can able to understand or can deal with only hardware address, and CPU always generate logical address. So we need one mechanism through which we can resolve this issue, and that mechanism is nothing but address translation. Means CPU will always generate logical address, but that logical address needs to be converted into a physical address with the help of address translation mechanism. And once it is converted into physical address, then we can contact or we can communicate with main memory, and then that process can be executed in the main memory. Okay, so with the help of logical address, we can directly, or we can say CPU can directly deal with secondary memory, because secondary memory can able to communicate with logical address. But with the help of secondary memory, we cannot achieve the desirable criteria that we have discussed in the previous session. Yes, if CPU directly deal with secondary memory, in that case access time would be very low, and that is not desirable. Okay, so that is the reason why we need to have one small amount of memory through which we can reduce the access time, and that is nothing but main memory. So if you want to deal with main memory, you need to use this address translation mechanism. And who is responsible to do this address translation? Operating system itself is responsible to do the address translation in this particular case. So this is one of the responsibility of operating system with respect to memory management, which is nothing but address translation. Now, moving forward to the next responsibility of operating system with respect to memory management, which is nothing but memory allocation policy. So, on wider perspective, there are two important memory allocation policies with respect to memory management. One is contiguous memory allocation policy, and second one is non-contiguous memory allocation policy. So these two policies are very important. Okay, and memory allocation topic in memory management is very important as far as any competitive exams is concerned, any university examination is concerned. So these things you have to keep in your mind, and you need to understand these things properly. So there are two types of memory allocation policy. First one is contiguous memory allocation policy, and second one is non-contiguous memory allocation policy. So let us discuss first one. What is contiguous memory allocation policy? So let us discuss it with the help of this figure. So in this particular figure, again we have drawn memory hierarchy with slight modification. Means what is contiguous memory allocation? Means the address translation mechanism we have discussed. Second responsibility of operating system is what? Memory allocation policy. So in early era we had this type of memory allocation policy. So as I told you, if you want to execute any process in the CPU, that process needs to be reside in main memory. So what will happen? You need to, if you want to execute any process in the CPU, you need to fetch, or you can say you need to fetch that program from secondary memory and put it into a main memory first. So how this memory transfer will take place? Yes, so there are two ways through which we can do these things. One is contiguous memory allocation. Means suppose if we have a program or is a process in secondary memory, because program is about to create when it resides in secondary memory. So if process P1 requires, say for example, a certain memory area, okay, to store in secondary memory. So how it will be stored in the main memory. So how it will be stored in the main memory from secondary memory? So in the case of contiguous policy, the whole process will be picked and it will be placed in the main memory area where the space is available. Where the space is available called contiguous memory location. Means suppose if any program require 10 KB of space in main memory, so it doesn't mean that that 10 KB of space is available at the starting point only. It doesn't mean that stuff. Means if 10 KB of space is available anywhere in main memory, in that case we can shift that process into a main memory. But the condition is what? The 10 KB of space should be available in main memory in contiguous fashion. So then and then we can shift that process into a main memory. So this is the contiguous memory allocation policy. Now let us discuss this contiguous memory allocation policy with the help of example. So before going to see the example, let us discuss non-contiguous memory allocation and then we'll switch to the example. So now the next one is non-contiguous memory allocation. So what is non-contiguous memory allocation? So in the case of this particular scenario, what is the difference? So as I told you, in the contiguous fashion, the 10 KB of space should be there in main memory in contiguous fashion. Okay. If 10 KB space is available and if it is available in scattered manner, like 1 KB is here and 2 KB is here, 3 KB is here, or scattered way, we have total 10 KB in main memory. We cannot store that process in main memory. In the case of contiguous memory location, that is a limitation of a contiguous memory location. But what will happen in the case of non-contiguous memory location? In this case, suppose if we have one program of 10 KB and that program needs to be executed in the CPU, so that program needs to be shifted into main memory. But right now, the main memory have a total 10 KB of space, but 10 KB of space, total available 10 KB of space is there in the main memory, but it is not available in contiguous fashion. It is available in scattered way. Yes. So even though it is available in scattered way, so what will happen? You can see in this figure, P1 is nothing but one process, and that process needs to be shifted into a main memory. So if 10 KB is not available in contiguous fashion, so first of all, that process is divided into a small number of chunks, and each chunk would be adjusted in the main memory as per its available size. So there are chances if 10 KB of file or as a process is shifted into main memory into a different location. So that's why it is called non-contiguous memory location. So it is advantageous as compared to contiguous memory location. We will compare both the type of memory location with the help of example. So first of all, we will see the contiguous memory allocation with the help of example. So as far as contiguous memory allocation is concerned, as I told you, we can store the process if we have enough space in contiguous fashion in main memory. Yes. So if you want to give the example of contiguous memory allocation, so in data structure we have one data structure. It is nothing but array. So you can see that this is nothing but array of 5 elements. So array store the element in contiguous fashion, or in linear fashion, or in sequential fashion. Yes. So if we have the base address of an array, and if you know the size of the array, so if you want to access any element, we can easily fetch. We can efficiently fetch any element from the array if we know the base address and size of the array. Yes, based on index value, we can can access that element very fast. Yes. So this is the advantage of contiguous memory allocation. Means access time is very fast, or the searching time is very fast. Okay. So let us discuss this contiguous memory allocation with the help of one example, and then we will discuss the pros and cons of contiguous memory allocation. So you can see in this particular example there are total 10 KB of memory is available, and out of 10 KB, 2 KB in center we have the word block, 2 KB is already occupied. Now in left hand side as well as in right hand side we have 4 KB and 4 KB size which is available right now. Yes, total 10 KB, 4 plus 4 plus 2, and 2 is reserved already. So 2 KB we cannot utilize. But 4 KB and 4 KB we have in separate chunk. In scattered manner we have in main memory. Yes. So if you are following contiguous memory allocation strategy, and if any process requires 5 KB of size, so can we accommodate this process into main memory by having this size of memory in this fashion? So the answer is no. Why? Even though what is the requested size? The requested size is 5 KB, and what is the total available space in main memory? 4 plus 4 is equal to 8 KB. So even though we have more than the requested size in main memory, okay, requested size is 5 KB and available size is 8 KB. So you can easily accommodate this process in main memory. But why we cannot accommodate it? Because it is 5 KB of space is not available in contiguous fashion. Yes, so contiguously we have only 4 KB of memory. So if you are following this contiguous memory allocation policy, you cannot accommodate this process even though the available space is larger than the requested space. That is the main disadvantage of contiguous memory allocation, and that disadvantage is nothing but external fragmentation. Means contiguous memory allocation policy always suffers from external fragmentation. So this is the main drawback of contiguous memory allocation, and the advantage of this contiguous memory allocation is, as I told you, this searching time is very fast because data is stored in contiguous fashion. If you know the base address, you can easily fetch a particular element in the array with the help of index number. Yes, with the help of index, you can easily fetch the value of a particular element. So searching is very fast, but simultaneously it suffers from external fragmentation. Okay. Now let us discuss non-contiguous memory allocation with the help of examples. So in the case of non-contiguous memory allocation, so non-contiguous memory allocation can be easily represented with the help of a linear data structure called linked list. So what is the scenario of linked list? In this particular figure, there are 3 nodes we have, and it is demonstrated in terms of single linked list. Yes, in which we have address of first node we have, and the first node will give the address of second node, and the second node will give the address of third node, and so on. We can reach to a particular element in the case of linked list. So what was the scenario in the case of array? If you want to search particular element, you can directly reach to that element. So that is the reason why searching time is very fast. But in the case of non-contiguous memory allocation, specifically in the case of a linked list, if you want to reach to the nth node in the linked list, you cannot directly reach to that node. need to have the address of first node. The first node will give the address of second node, and second node will give the address of third node, and so on. You can reach to the desired element in the linked list. Yes, so that is the main, we can say, drawback of non-contiguous memory location. Means the searching time, or we can say access time, is very slow. Okay, so let us discuss the concept of non-contiguous memory location with the help of this example. The same example I have taken. The 10 KB of space we have, out of 10 KB, 2 KB is already reserved. So we cannot utilize that 2 KB of space out of 10. Yes, but we have, we can utilize 4 KB and 4 KB, and it is available in scattered manner. So if a same request is arrived, like if any process require 5 KB of size to accommodate in a main memory, so what will happen? These requests will be satisfied by the operating system. Why? Because we are dealing with non-contiguous memory location, as I told you. In this case, the requested size is less than or equal to the available size in the main memory. Means 8 KB of size is available, but it is not available in contiguous fashion. Even though it is not available in contiguous fashion, still we can utilize those memory area, okay, to satisfy this request, because we are dealing with non-contiguous. Okay, so what I will do? So I will give the 4 KB of size to the first block, and then the remaining 1 KB will be given to the next 4 KB block. And then if you want to reach to that element, we can provide the address of the second 4 KB block, so that you can reach to that particular information for execution. So this arrow represents the address of the next node, so that we can reach to that information for the execution. So what are the advantages and disadvantages of non-contiguous memory location? So non-contiguous memory location never suffers from external fragmentation. This is very big advantage of non-contiguous memory location. But simultaneously, it suffers from slow speed, because we do not have the address of all the nodes with us. We can reach to a particular node by traveling from first node to second node to third node to fourth node onwards. We can reach to a particular node for searching that stuff. Clear? So these are the scenario of contiguous and non-contiguous memory location policy. So in this particular session, we have discussed the two important responsibility of operating system with respect to memory management, which is nothing but address translation, and second one is memory location policy. In memory location policy, it is further divided into two categories. One is contiguous memory allocation policy, and second one is non-contiguous memory allocation policy. So I hope it was clear to you. Thanks for watching this video. See you in the next one.